Hi, welcome to today's class. The topic, as you can see, is Ionic Theory. Before we go into the Ionic Theory proper, we will be talking about electrovalent and covalent compounds. What are they? Electrovalent compounds are otherwise called ionic compounds. They are formed when electrons are transferred from one atom to another atom. As you can see in this image, electron from this atom was transferred to this atom. So the compound formed by this process are said to be electrovalent compounds or ionic compounds. One special thing about ionic compounds is that electrons are negatively charged, and then when electrons leave an atom, negative charges leave the atom. So this means that the atom becomes deficient of negative charges, and as such it becomes positively charged. When an atom gains an electron, it means it acquires negative charges, and then this makes the whole atom to be negatively charged. So the atom losing the electrons become positively charged, and then the atom gaining the electron becomes negatively charged. According to the law of electrostatics, unlike charges attract. So this means that this atom will be attracted to this atom by what we call electrostatic forces of attraction, and then every atom in this compound will be attracted by neighboring atoms in this fashion. So that is why ionic compounds have high melting and boiling points, because it will take a great deal of energy to separate the bonding caused by this attraction, by these electrostatic forces of attraction. They are usually hard, and then they are soluble in water as well, for many of them anyway. Covalent compounds are formed when electrons are shared between atoms. As you can see, this doesn't involve the transfer of electrons, but the sharing of electrons. So electrons are shared here between hydrogen and carbon in this molecule. So this is called covalent bonding. Covalent compounds generally have lower melting and boiling points, because the forces that hold the molecule together are weaker than the electrostatic forces of attraction. Now, generally, electrovalent compounds are formed between metals and non-metals, because metals generally tend to lose electrons and non-metals tend to gain electrons. And then covalent compounds are formed generally, most times, between non-metals. They share electrons when they react with each other. So there may be a few exceptions, but on the larger scale, non-metals react with metals in an electrovalent combination, and then non-metals react with themselves in a covalent combination. Okay, let's quickly talk about electrolytes and non-electrolytes. What are electrolytes? Electrolytes are substances that dissociate into ions in water or in solutions and then conduct electricity. Water is the universal solvent, is the most common solvent you will come across on Earth. So, however, there are other solvents that are not water. So electrolytes will dissolve and then dissociate into ions in solutions, and then because they have dissociated into ions, they can conduct electricity. So for example, sodium chloride is made up of sodium and chlorine. When you add sodium chloride salt into water, the water molecules will break them down into sodium ions and chloride ions. Remember, sodium and chlorine reacted by loss and gain of electrons. electrons was lost from sodium, and then electrons were gained by chlorine. So this makes sodium positively charged, and then this makes chlorine negatively charged, and by that they are called ions. Charged atoms are called ions. So however, in the solid state, they are not free to move. They are held together by strong electrostatic forces. However, when they are dissolved in water, the water splits them down into ions, positive ions and negative ions. And because they have positive ions and negative ions, they can conduct electricity. If you melt electrostatic compound, or rather electrovalent compounds, ionic compounds, their ions become free as well, and they can conduct electricity. So electrolytes are substances that dissociate into ions in solutions, and when melted, when molten, to conduct electricity. Non-electrolytes are basically covalent compounds. For example, sugar. Sugar, though, dissolves in water, but it's a covalent compound, and as such would not conduct electricity in water. So I basically explained what non-electrolytes are. They do not dissociate into ions and do not conduct electricity when they are in water. Okay, let's talk about weak and strong electrolyte. The strength of an electrolyte is determined by how much electricity it can conduct when dissolved or when melted. And then that's also determined by how much ions it can form, especially when dissolved. When a lump of an electrovalent compound, an ionic compound, is dissolved in water, not all the molecules, not all the molecules will form ions. Some will dissociate and some may not dissociate. When all the substance dissociate to form ions, it is usually a strong electrolyte, because there are so many carriers of electricity in water or in the solutions. But when only few, as you can see here, dissociate into ions, there are lesser carriers of electricity. So here there are more ions to conduct electricity, and here there are few ions to conduct electricity. So strong electrolytes are those ionic compounds that dissociate completely in solutions, and then weak electrolytes are those ionic compounds that dissociate only partially in solutions. So because of the strong electrostatic forces in some compounds and other interactions with water, some may not dissociate completely, and as such they will only conduct electricity partially or to a reduced extent, while those that dissociate completely will conduct electricity very well. So if you connect a circuit and a bulb to a strong electrolyte, the bulb will be expected to be brighter than when it is connected to a weak electrolyte. And of course, a non-electrolyte will not even conduct electricity at all, so the bulb will not even come on at all. So that's the difference between weak and strong electrolytes. Okay, example of strong electrolytes are usually compounds of very reactive metals, such as sodium chloride, sodium fluoride, calcium chloride, aluminium, not aluminium now, potassium sulfate, etc. Weak electrolytes are usually organic acids are weak electrolytes, and then other ones that will dissociate partially in solutions. For example, Sodium acetate dissociate partially in solution, and then other organic salts dissociate partially in solution to form weak electrolytes. Okay, let's talk about conductors and non-conductors. Conductors are substances or materials that allow the flow of electricity or electric current through them. Conductors conduct electricity by the movement of free electrons. So conductors basically have free electrons. You may be asked to differentiate between conductors and electrolytes. Electrolytes conduct electricity by the movement of ions, mobile ions, while conductors conduct electricity by mobile electrons. So they are quite different. Electrolytes conduct electricity either in solutions or when they are in molten form. Conductors conduct electricity usually in the solid form. So those are the differences. Examples of conductors are silver, gold, copper. Mostly metals are good conductors, and then non-metals are not good conductors. So non-conductors do not conduct electric current. They don't allow electricity to pass through them. Sometimes they are called insulators. Non-metals are usually non-conductors of electricity. In other words, they do not have mobile electrons that will carry the electric current. So they generally will not conduct electric current. They have electrons, but the electrons cannot move. They are not mobile. But in the case of metals, electrons are mobile and such conduct electricity. Examples are glass, rubber, oil, plastics, etc. Okay, so what is the Ionic theory about? First, there is the Arrhenius Ionic theory. He said when an electrolyte is melted or dissolved in water, its molecules, take note of the word molecules, dissociate into ions. This process is known as ionization. It results in positively charged ions and then negatively charged ions. Some of the positive ions can be metallic ions or ammonium ions or hydrogen ions, and then non-metallic ions are hydroxide ions, sulfate ions, chloride ions, sulfide ions, etc. So don't forget, Arrhenius Ionic theory states that when an electrolyte is melted or dissolved in water, the molecules that make up that electrolyte break down into ions. So it assumes that the ions were not there. So that subtly now, they are only formed when they are melted or when they dissolve in water. That's the subtle assumption of Arrhenius Ionic theory. As we go on, we'll talk about the modern Ionic theory and its modification to the Arrhenius Ionic theory. So once there are ions in water and electric current is connected, positive ions will move towards the negative side of the electric current, which is called the cathode, and the negative ions will move towards the positive end of the electric current, which is called anode. So in electrolytes, electricity is carried by movement of ions. It's very, very important. In conductors, electricity is carried by movement of electrons. So basically this is what we are saying. The cathode is negatively charged and then would attract positive ions. The anode is positively charged and will attract negative ions. So ions that move to the cathode are called cations, short for cathode ions. So we expect metallic ions that are positively charged, and then ammonium ions and hydrogen ions to be attracted towards the cathode, and then non-metallic ions and hydroxide ions to be attracted towards the anode. So what we are saying is non-metallic ions are usually negatively charged and are usually negatively charged and are called anions. And then metallic ions are usually positively charged and are called cations. So the same diagram here. This is the electrolyte. As you can see, the cations are moving to the cathode, and then the anions are moving to the anode. These other ions will separate eventually. Okay, the modern ionic theory states that even in a solid state, electrolytes are made up of oppositely charged ions. These ions are pulled apart when the solid melts or dissolves in a solvent due to the applied heat or solvent molecules. So, the Arrhenius ionic theory states that these ions are formed when these molecules dissolve in a solvent or are melted. But in reality, that's not the case. Ions are always there, even in the solid state. But the differences between the liquid state and the solid state is that they are not mobile, so they will not conduct electricity. So when melted, they do conduct electricity, or when dissolved in a solvent, they become mobile and can conduct electricity. So ions are present in solid ionic compounds and become mobile when melted or when dissolved in a solvent, is the modern ionic theory. So take note. So thank you. You can go through this task and then see to test your knowledge of what we've done so far. Trying to make it smaller to see if every okay. Yes.